So the plenary session provided a good summary of the challenges we face in terms of climate change, inclusivity, and biodiversity. And there are a range of potential solutions that we can use to address these challenges. In our most built environments, a gray-only solution like seawalls may be most appropriate. And on the other end of the spectrum, a purely green solution like mangrove restoration may be best. So green-gray infrastructure is an ecosystem-based adaptation strategy that draws upon the best of our engineering achievements to create hybrid solutions along this spectrum. So everything that we're doing within our green-gray program at Conservation International is working to fundamentally transform the engineering and construction industry to design and build with nature, to create the next generation of climate resilient infrastructure. And there are some key barriers that we've identified to achieving this goal. And there are two that I want to discuss today. One is that engineers, developers, industry, and governments lack experience, familiarity, and consequently confidence in the reliability and application of green-gray approaches. The second is that technical knowledge and data needed to standardize reliable green-gray solutions is not broadly or equitably available. So this is how I interpret our problem statement as it relates to these two barriers specifically. So given the lack of accepted norms and standards for green-gray infrastructure design and engineering, how might we increase the experience, familiarity, and consequently confidence of engineers, developers, industry, and governments so they can design and build green-gray infrastructure projects that protect, manage, and restore nature for communities and future generations? So to back up a little bit here, what is an engineering design standard? Generically, it includes a description of the approach, the purpose, the benefits, and constraints of the engineered system. It also includes general design principles for the sizing, operation, maintenance requirements, and costs. A standard also typically includes design details, usually drawn in AutoCAD, and finally design specifications, which are a Word document with detailed instructions for the builder. So descriptive methods usually include the first two of these, and standards include all four. So my experience is that there's flexibility in what level of detail is included in an engineering manual or a guidebook. Engineering practice generally is driven by codes and standards with prescriptive requirements that each component of a project is built to a certain standard. Compare that to a performance-based approach where all of the elements in a project work together to perform to a certain standard. So I want to share an example from a design guidebook for green stormwater infrastructure that I worked on a couple years ago as a consultant for an alliance of cities in the San Francisco Bay in California. We started by defining typologies, described the approaches, provided general design principles, typical design details and notes, and specifications. And this is an example from a project where we used resources in the guidebook to design and build a project. These types of standards are a key component of decision-making, especially at the everyday level of practicing engineers. So the fact is that there are few accepted engineering standards for green-gray infrastructure solutions, but there are many guides and resources that give us enough information to begin. So today we are going to hear from two colleagues. First, Ellis Penning from Deltares, and then Katerina Schmidt from GIZ, who will share their experiences with barriers to ecosystem-based adaptation in the infrastructure and engineering sectors. And then we'll introduce one idea of how we could move forward to address the problem statement and move into a discussion to get your feedback on these ideas. So please join us on Mentimeter to join the conversation. And with that, I now welcome Ellis to start sharing her screen.
Thank you very much, Emily, and it's a pleasure to be here. For those of you who do not know me, I am an aquatic ecologist working at Deltares, where I lead the research on nature-based solutions. So there's different wordings being used for basically similar concepts. So ecosystem-based adaptation is one of the ways to talk about nature-based solutions. Also, the green-gray infrastructure is part of that. I hope that you see my screen well. Is that correct?
We see it.
Okay. Excellent. So today I want to give you a few experiences that we have with ecosystem-based adaptation for resilient infrastructure. As we all know, climate change can have devastating effects in terms of increased flood risks and extended periods of droughts, and erosion, landslides, fires, and that has impact on infrastructure as well. So if we want to talk about resilient infrastructure, we really have to think about, okay, what are these climate change challenges that we're facing? And they are different depending on where you are in the world. And they are in Europe, here you see some of these climatic zones, and per climatic zone, some of the examples of effects of climate change that we are facing. Now, interestingly, there is a nice example project in the Balkans, Western Balkans in Europe. They are one of the most vulnerable areas in Europe related to climate change. And there, also these photos that I showed in the first slide are coming from where they have been really severely impacted by climate change. And this lady here, Neda Malecic, she is talking in an interview in this project. You can look it up on the website of the IUCN about that they need to really work on improving their or like restoring their infrastructure again. And then she also says that she sees nature-based solutions and ecosystem-based adaptation as a part of that solution to work towards it. So I would also emphasize that they are an additional set of measures in overall strategies to work towards resilient infrastructure. And it's not only strategies that are like the green and the gray hard measures that we can think about, but it's also other measures, right? We're talking about what's the initial risks and what type of risk reduction measures can you think of? And they might relate to zoning or building codes. They may also relate to early warning systems. So there's a whole set of measures that you have to think about. And obviously, well, this one comes from a study on mangroves, so that they fit in there. And all of these different types of measures help in reducing those risks. So it's always about really linking that. And if we're talking about resilient infrastructure, we have to realize that these are within a catchment. So a catchment approach to this disaster risk reduction is really needed. And if we're thinking about catchments and what is currently happening kind of worldwide, well, this is a picture made in the Netherlands, so I'm not sure whether your landscape looks exactly the same, but we are facing, for example, groundwater depletion due to a high demand via agricultural use, but also resulting soil erosion and rapid drainage. But in cities, we are talking about heat stress and flash floods due to hard pavements, but also other aspects like the chemical pressures on our natural water systems and the effects that has on how well it functions. And the hydromorphological pressures that we may have put in place by channelizing streams or by putting in the hydropower dams or levees to restrain rivers to flow where we want them to flow. So that is kind of the current situation. But if you're talking about thinking about resilience in a larger way, you really have to say, okay, there's in all of these different aspects, there are solutions that can be taken, ranging from sustainable agriculture, to natural functioning of river systems, improving the water quality and quantity aspects, and urban resilience as well, right? And if we're really talking about the effect of, for example, flash floods, we can think of, okay, in this current system, you might experience that during a rain event, the peak during the rain event is very high, and it's very short, and then it really drops down quite quickly over time again. And you also see that then afterwards, the base flow is very low. Now, in a system that would respond more normally, more naturally to such a rain event, you would think that, of course, there's a more sponge functioning in the landscape, which creates that the peak is less intense. And if there's a less intense peak, there's also less flood risk related to that. And the same is for risk related to droughts, because The sponge function will slower release the water back into the system, and therefore also giving you an improved base flow and more access to water during dry times. Now, this is kind of the ideal world, right? And this is what we want to work towards. And one of the ways to do that is what we call also natural water management or natural river management. Just to really think about these in the catchment scale. How can we improve that sponge functioning? Because it will relate to reducing water-related risks, floods and droughts, increase the groundwater levels, etc., but also increase biodiversity values, for example, and ecosystem services related to it. So it goes wider than only your infrastructure resilience, but obviously you should think of it as a whole, right? And there's different, oh, I go too quickly, and a really nice one is the Room for the Rivers project in the Netherlands, where we were facing some serious floodings in 1993 and 1995, and that led to the realization we need to really start treating the system, the ecosystem, at the scale where we can really solve these problems better. And this has been a long-term commitment to give more room to the river and thereby reduce the vulnerability of the system, and especially the infrastructure related to that for the flood risks that we were facing. Now, what you see here is also that it's written here very smallly. There were 34 projects in total within this larger scheme, and here you see them in the left picture. With stakeholders together, we really looked for what is the best measure in the right location, and how do we evaluate that in a good way. Now, I can talk about that for another 20 hours easily. I will not do that, but there's a nice research paper on that I want to refer you to, that is here in the bottom corner. And another nice one is the Adaptation project in Scotland as a quick example, where they've basically been looking at the same issues, like how can we increase the sponge functioning in this landscape to reduce the risks for infrastructure, but also for the farming communities in terms of floods and droughts. So they have been putting in, for example, natural water retention ponds, and they've been renaturalizing streams and reforested upstream areas. And this was done together with all the stakeholders and local people and local farmers also. And that really made them successful. So if we're talking about, like Emily already said, like there's some barriers to the implementation of these ecosystem-based adaptation measures. Actually, I want to turn it around a bit, and I want to say, listen, there's also a lot of enablers. We know really quite a bit already about that. And if we're talking about enablers, they're not only in the technical domain, but they're also in the socio-economic and the governance domain. These 6 were defined by EcoShape. They are a Dutch consortium of the private industry, dredgers, consultants, universities, research institutes like Deltares, and in coordination with the government, responsible organizations. These have been defined. Like, if you really understand your system very well, like the technology in the system understanding, if you really acknowledge that these are multi-stakeholder undertakings, and you also think about the maintenance and monitoring of the different measures that you put in place, you get quite far. But you also need institutional embedding and thinking about the business case. There is financing a part of this. So make a cost-benefit analysis that not only judges the merits on its technical functioning, but for example, also on socioeconomics of the different groups, but also for biodiversity. Now, the 6th enabler is capacity building. That's basically what I'm doing here as well, right? We're talking about these types of solutions so that you can start evaluating them aligned with the more traditional methods that you might be used to. And next to implementing these nature-based solutions or ecosystem-based adaptation measures, like what you may call them, I think it's also good to rethink current infrastructure designs. And here, this is a nice example. This is twice the same photo, twice the same location. You see there were 2 solutions. The first one is obviously an inappropriate design, wasn't really helping the people, caused a lot of troubles with upstream flooding. But changing that, it's a fairly simple measure, actually. A lot of problems were solved. Well, I'll leave it with that, and thank you for your attention.
Thank you so much, Alice. And I really appreciate the change from barriers to enablers. and some of those being key to the question about engineering guidelines. So with that, Katerina, welcome your perspective and input.
I'm looking for how to stop sharing my screen, or did that already happen?
I think I can take you over.
Yeah.
There you
go. Great. Yeah, hello everyone. My name is Katarina Schmidt. I'm an advisor in the Global Program in Climate Services for Infrastructure Investments within GIZ. And my input will be much shorter, but I wanted to share one example of how we're approaching the topic in our project that is very much focused on gray infrastructure, and where we mostly work with one specific tool that's called the PyVC protocol. It's a risk assessment methodology originally designed by engineering associations in Canada to strengthen infrastructure, originally to keep up with heavy snow, but in a way it's of course available for any other climate induced hazard or event that might cause stress on infrastructure. We as a global program act more as a broker, where we try to bring the protocol to other contexts, and it has successfully been applied in many different countries. First of all, Costa Rica, 2010 was the first application, and now it's been shared in other contexts. And as a protocol, or as a type of assessment methodology, it focuses a lot on climate services, on climate information, and then on the infrastructure performance part within or faced through these climate effects. And what we've been discussing a lot, or hearing as feedback as well, that what is a bit missing is the whole systematic aspect of the surrounding ecosystem that the infrastructure is based in. Because of course infrastructure is never being on its own or in a void, but of course the surrounding is important. So what we're trying right now, and now it's working, is to try to integrate a little bit what my predecessors have said already, that there is a lot of guidance out there, also of course related to EbA approaches. And what we're trying right now is to basically bring these two tools together, using mainly something that we've also been using within GIZ that you might know of, and where we're trying to basically reap the benefits of this more system thinking approach within the protocol that has been been familiarized already with lots of in the engineering sphere, and then see how to bring it to fruition, and hopefully some pilot case are similar. Thanks.
Great. Thank you so much, both to Katerina and Ellis. I think this really demonstrates that there are a lot of different aspects around the world where we are piloting projects. We have good demonstrations of how green, the ecosystems can work with and complement conventional infrastructure, developing different risk assessments and tools. And so how in this process can we provide engineers around the world who are eager to design projects to achieve these multi-benefit outcomes that green gray infrastructure has to offer, the information and confidence about performance in the absence of standards? How can we develop and provide robust tools like PyVC and best practices for estimating project and performance-based outcomes? And unfortunately, the current approach to evidence-based decision-making for green gray infrastructure is at best project, region, or problem specific. At worst, it's non-existent or proprietary. And regular monitoring of infrastructure performance and impacts, which is one of the enablers that Ellis introduced, is necessary to generate data, which should be available to all stakeholders. So we can systematically learn by doing. And I want to describe a path forward for us to consider that uses an evidence-based decision-making feedback loop where we can collaborate across disciplines and geographies to design a trusted, modern data sharing platform for users to input technical knowledge and data about green-gray infrastructure projects. We can design a platform that leverages modern computing and data collection technology. When comparing the supercomputers we now all have in our pockets, in our phones, to early computers, what could the modern engineering standard look like? We can use online database structures and open source knowledge platforms like the International Best Management Practice Database, which I think was pivotal in building confidence and comfort specifically for green stormwater infrastructure, especially in the design and regulatory communities. We can link to existing frameworks like PyBC or like infrastructure pathways, which provides the benefit of taking a life cycle view to encourage collective action and system approaches. So imagine multiple pathways, one each for different types of green-gray infrastructure solutions layered on top of this framework. We can build and implement a system by and for users to input knowledge and data with a focus on crowdsourcing information about green-gray infrastructure technology, performance, and cost to inform descriptive methods. For example, for different types of green-gray infrastructure projects, we can define a common set of key performance indicators and monitoring variables to create consistency within the platform. And we can incorporate cost-benefit analysis, another enabler, with input data and outputs to build a database of social, economic, and environmental costs and benefits associated with different types of green-gray projects. So who are the users of this platform? For practitioners, designers, and engineers, we need to capture and consolidate project data, details, designs, and specifications to capture the best available scientific and technical information about performance, costs, and benefits in technology. We also need to capture case studies to share with audiences outside the engineering community, policymakers, economists, and financiers, to be able to communicate with investors and funders this intrinsic value of green-gray infrastructure projects to support sustainable development, with potential to link to a project pipeline, connect project developers and with financiers in a type of project matchmaking service. And these are a couple quotes from a recent workshop that I attended, that we need frameworks to be inspirational, to help people imagine what it is they can do. We need to manage and maintain this platform and learn collectively. The data needs to have open access to all so it can be broadly and equitably available. Ideally, the platform would have a real-time feedback loop from practitioners, designers, planners, and financiers. We can learn from successes and, importantly, failures and share that information widely. It's important to implement projects using an experimental design approach to project implementation so we can learn by doing, with periodic reviews, compilations of common themes, outcomes, findings from this modern engineering guideline in biennial reports. It opens up opportunities for powerful interdependency assessments. So this result is what I will put forward as a natural infrastructure engineering hub, an international resource for how to design, build, monitor, importantly, measure, maintain, and adaptively manage nature-based engineering solutions that closes and shortens the feedback loop between discovery, application, and advancing practice, and gives engineers and regulators access to information to increase confidence in outcomes. So now we want to hear from you. That was a lot of information, a lot of talking. Please join us on Mentimeter or raise your hand or add to the chat in the conversation if you have a question or a comment. I am just quickly going to share the Mentimeter inputs we have so far. So we've heard from 8 people so far. Let me bring this one over. There's 9. So we have a good representation. It looks like California and Germany are strongly represented. with the folks who are participating here. And this is great. Most of the respondents fit into none of these categories. So I would love to hear where folks are from, because this wasn't enough choices. So I'd love to find out where your expertise is. And maybe the first question is, do you think a natural infrastructure engineering hub would be potentially helpful, new and useful, or duplicate existing resources? And it looks like most of you think this could be potentially helpful. So I'm going to stop sharing and would just, or maybe I'll keep sharing. You guys let me know if it's helpful to have this showing, but would just love to hear what folks think. If you think it would be duplicate existing resources, for example, are there existing resources out there that you think we should know about that this would be duplicating?
Thanks, Emily. There's a question in the chat. I don't know if you can see it whilst you're sharing.
I can.
Good.
I have to find it though. Let's see. Could you go ahead and read it, Erinda?
I can do that. Or maybe
Great.
Nike, you want to unmute yourself and
Yes, thank you very much. I can also put my question directly. So it actually fits very well in the question about the engineering hub. So I think actually on nature-based infrastructure, on green infrastructure, there is a lot of information in some countries and in some regions. As for example, I studied in Germany engineering, and there I think every city, every town, you can find a guideline on how you would build a green swale for stormwater management and so on. But now I'm based in Cambodia, and I have the feeling that here I can't find any guideline on that. So, and I think the consequences here are quite different. So you would have to think about problems like, for example, mosquitoes, having a long time standing water in a swale in the city town would cause much problems with mosquitoes here. So, or you have to deal with wet and dry season. What happens if it's 6 months or 5 months not raining? What happens then to your swale? And I think this is something where we are missing information, and where I'm missing a data hub or a platform where we could exchange experience on this. Yeah,
that's
thank you.
Great. Thank you so much for that input. That's really helpful. Any reactions or other questions to the idea or the comment there?
I saw that Felipe posted a link, and I'm not sure if he's trying to answer Nike's question with that link. Do you want to say something?
Thanks, Elina. No, I just wanted to share the Cydia manual. I'm not sure if you all know it. It's a little bit about what Ms. Hesteman was talking about, guidelines on how to build sustainable urban drainage systems. And this is a little bit of what we heard also from Elise on the guidelines, all the details that you need for building tree boxes or parking lots with permeable concrete and things like this, So I think there's a lot of knowledge, as a couple of you were saying, regarding sustainable urban drainage systems in general, right?
Exactly.
Which is sort of a mix between green and gray infrastructure.
Exactly. So then the question is, how can we accelerate that type of information and that level of detail for other types or combinations of green and gray? So for example, ecotone levees. So these are combinations of earthen walls, if you will, combined with ecosystem restoration on one or both sides of that levee. Right now, those are in an experimental pilot phase. Similarly, mangroves and seawalls. That's one example of where we know a good amount about mangrove restoration. We know a lot about how to design a seawall, but how do we design those to function and perform together to meet standards? with that, I'm going to move to the next question. So this question is, would you participate in creation and data sharing required for this modern engineering guideline? So there was yes, 3 response, and potentially. And one person said no, I'd love to hear why not. And one person said only if financially compensated. I will note the other choice that it looks like no one has clicked here yet was only if required by regulations. So if governments or your permit for your project was forcing you to have input back into that. Anyone want to share why they chose one spot or another in this? I'm all for big, long, awkward pauses, so, but I will go to the next question. So this one is, how could we create a data feedback loop back into this type of modern engineering guideline? So a little bit of a different way of asking that first question. So could we have projects or permits require it? Could we have reimbursements or payments, that financial contribution, awards or acknowledgement, country commitments and international convention, used and promoted by infrastructure, finance, and funding institutions? And it looks like the majority of folks, and this is only a response of 6 participants, so a small sample size, weighted towards awards or acknowledgement. What do you guys think? Would that work? If you were kind of acknowledged in some way or awarded, publicly recognized for your contribution, would that be sufficient motivation?
I'm a little bit confused. Sorry, I see that Anna has raised her hand.
Oh, let's do Felipe and then Anna and then Ellis.
So me
So
first?
Yeah.
Okay, thanks. So I'm a little bit confused about the question, right? Do we need information back on how these infrastructures are really reducing vulnerability and exposure? So how unproved technologies that we're, putting out in the world are really. Okay, so I think there are different things here. One would be, for example, low-cost monitors and automation to try to get information in a big way without a lot of investment in time or resources, right? So that's one way that we could definitely get a lot more information in.
Good point.
Yeah, and definitely in policy, if you put it into the regulation, then things sort of fall into place. That's a little bit what I was thinking.
That's great. Thank you so much. And Anna.
Thank you, Emily. The first point is about this particular question you just asked about the feedback loop that some of us answered, but I think it has to be almost a question as to a higher level. It's not going to be an individual engineer decision as much as the company that employs that engineer or the government department we are working at. And then we run in all the terms of, are we as an institution sharing our knowledge publicly or not? Do we want to allocate the resources to do that? Because we know that many of us bill by hours. So that it has to be driven, of course, by engineers who have to see value in this, but we'll need to also go to that other level of engagement. And linked to this is also a matter of getting a lot of information is not the goal. I think getting a lot of good information is the goal. So how do we do quality control? How do we filter? How do we homogenize? coming from a traditional engineering background, what I do love of many standards and manuals is that they come with almost a higher authority that has done all that work. Here in the US, it's going to be the Army Corps, for example, for the coastal engineering manual. In Europe, it's going to be the Eurocodes. And a lot of that, the value of those manuals is not only the technical information that they provide, but it's also the peace of mind.
Yeah.
So I think that's an element to integrate. Thank you.
Beautiful. Thank you. So well said. That confidence is so important. Ellis, and then we'll go to the next question.
Yeah, I completely agree with what Anna is saying, that you do need to have some sort of an incentive to really start doing this, right? And what I do see now in the Netherlands that is happening is that governments are more and more saying, okay, if you're going to implement like the EbA type of solutions, there's not only the implementation as such, but there's also a period of aftercare in which the constructors are required to maintain and to ensure performance. And this is an excellent method to say, okay, so therefore you also need to monitor if the performance is happening. And if this extra loop is made, you can get that feedback loop running. But it is indeed a part of the response, and it costs money, right? So there must be that incentive being given to that. But be aware that like this disconnect that there's often between implementation and then what after. That is really where you have an enabler to say, okay, if we link these together, people are much more responsible in this part.
Yep. Great points. Thank you so much for that input and thought. So I'm going to go to the next question here, which has to do with, I would say to some extent, Anna, one of the points you mentioned about the confidence and the quality of data, and Felipe, one of the points you mentioned about needing to have cost-effective monitoring equipment, if you will. And so one idea or one potential is to leverage citizen science and our community and the communities who are living and working around these projects to be part of the data collection and feedback loop. And so the question here is, how could we, assuming we think that is a reasonable idea to leverage citizen science, how could we enable those inputs to become a part of that confidence that we generate by producing this modern engineering guideline? I love the one person, if you could add in the chat why you think we shouldn't and it's not possible. I want to hear what your reason is. It looks like most, and this is only a sample of 8 people, but important to align citizen science efforts to specific data needs. So having those projects and those data collection efforts be linked to the monitoring that's designed very specifically. And then addressing bias among scientists and engineers is also very important. And then requiring extensive review. So any comments on why you selected one of these as particularly being an enabler, or reasons why we shouldn't, even if you're not that one person? I'd love to hear what are the cons about engaging with citizen science efforts. Great. Thanks, Felipe. Data quality. Do you want to say any more about that? Just the kind of that lack of trust potentially in the reliability of the data being collected, I'm imagining.
Exactly. So that's a little bit the problem that we have, for example, with complementing hydrometeorological data, captured, for example, by meteorological services, research institutes, with private sector, for example, data, right?
Yep.
And comparing the information that in the data that can be captured by a $300,000, complex installation and a $10, homemade or a low-tech gadget that you can deploy. I think each one of these have their value,
Yep.
I think involving people in data collection, monitoring is crucial and very important.
Yep.
I think, air quality, for example, is something that engaging people in this, raises awareness, it makes people more willing to bike instead of drive, etc. But there's definitely a place for high quality data and everything related to this. And another place, it's complementary, but not. I mean, you shouldn't like mix them in the same bowl and say, this is the information that we have, and these are the conclusion based on all these data sets.
Yeah. Ooh, that sounds like a really interesting project to kind of take remote satellite, citizen science, and low cost monitoring equipment and see how that data collection is complementary or in contradiction. Is it Blessing, Sharuka? Thanks for raising your hand. Welcome you to come off mute and add.
Yes. Sorry, my internet is a little bit slow. Yeah, I just wanted to add that to put in a local context, like where originally where I am at, where citizen science is not actually given due regard as at present, because of usually for nature-based infrastructure.
Sadly, he froze for me.
Which then.
Oh, sorry.
Yeah, so I was saying that. Yeah. Sorry, my internet is not so strong, so I'm having a little bit problems. But I was saying, to put into local context, the legal framework or the regulatory framework for nature-based solutions is to be present for this to be effective. Because currently, most of the data collection is rather, scientists go, they discover, they do data collection, and then they use it, and the citizens are not actually included in the whole process. Thank you.
Great. Thank you so much for that input, and thanks for working with the internet quality. So I'm going to go to the last question quickly, and then we're going to close out. So just to say, there were 4 barriers that I introduced. This is just kind of one pathway to address 2 of those barriers. So what other critical pathways do we need to address? So funding early stage project incubation for projects with green-gray potential. Similarly, thinking about finance around green bonds for sustainable urban drainage systems. Adding to engineering curriculum, capacity building, and professional training, absolutely. I love this. Green should be the first option and gray only used to complement. Therefore, more policies, regulation, and enforcement isn't needed. For example, obligation to build green rooftops, to foster infiltration, to plant trees, to leave rivers space. Great. Thank you so very much. We are just at time, and I'm going to let's see if I can do this very quickly, to say one more thing. And that is that we are in a really critical moment. This diagram is a map of the design thinking process some of you might be familiar with. So we have a deep understanding of this challenge. We've articulated the problem that we want to solve, and we've started brainstorming potential solutions. So as the next step, we can convene an international panel of cross-disciplinary green-gray, nature-based solution, ecosystem-based adaptation solution experts like yourselves who are here that represent engineers, developers, industry, governments, and finance. We can brainstorm together how to address the problem and create an infrastructure pathway with inputs from end-to-end information. We can prototype a set of 3 types or combinations of nature-based green-gray infrastructure engineering solutions. I mentioned mangroves and seawalls, living shorelines, and ecotone levees as 3. Then we can test, we can iterate with patience and, importantly, intellectual humility between practice, policy, and partnership to create this knowledge generation loop, which of course all takes time, money, and very hard collaboration. So I want to thank you very much again for joining this breakout session and starting